Welcome everyone to Build 43 Part 1. This system has more GPUs than any other system that we've ever built. We've done a lot of Quad SLI and Crossfire builds back in the day, but this system has 7 GTX 1080 Ti's, and we're using EVGA for the Win 3s, which have a 280 watt TDP. We're also using dual Xeons in this build, the Intel 2620 V4, which only have an 85 watt TDP, 128 gigabytes of Kingston ECC registered memory. For storage, a couple of 500 gigabyte SSDs and a Western Digital Black 2 terabyte. So if you do the math on the maximum power consumption of this system, it's going to be very close to the limit of an Australian PowerPoint or the entire house circuit of 2400 watts. And certainly if you did any overclocking here, which is not going to happen on a workstation where reliability is really the most important thing, you'd only need to push the GPUs to their maximum power limit, and yeah, you're going to be getting very close to that limit. So actually for testing, we're going to be splitting up the power as much as possible on a couple of different circuits just in case. And we're also using Corsair AX1600is, 2 of them in this build. So we are going overboard with the power and the cooling because this is a workstation. It needs to run 24/7 stable, never overheating. Reliability is absolutely key here. And also this platform is going to be upgraded for many years to come. So the case, the cooling system, the power supplies, custom cables, everything but the core components could remain for, well, I don't know how long, but many years. So it needs to be extremely reliable. The GPUs will be the first thing to be upgraded, and then probably next year, the motherboard, the CPUs as well. So the GPUs are actually going to be upgraded to 2080 Ti's probably later this year. So the platform is the most important thing here, and the case that we're using is absolutely perfect for this system. The CaseLabs Mercury S8 with its horizontal motherboard tray, which is HPTX. I'm working on some motherboard tray mods to deal with the immense amount of weight of the GPUs. I just built a 6mm piece of acrylic which is going to sit under the edge of the motherboard tray, because not just the motherboard was sagging, also the motherboard tray, the panel under the motherboard, and the bottom panel of the case. The entire case was bowing in half. And this is a CaseLabs case. It's high quality, it's strong, but it just could not handle the huge weight of the GPUs. So I spent a lot of time sorting out that problem. Also, considering I need to ship this build, it definitely needed to be strengthened, and I'm going to have to build some braces to fit in between the GPUs and the radiators for shipping. Otherwise, they'll just come straight off the motherboard. My favorite part of building this system was the loop design. It normally is, but for once, the loop design really mattered. I mean, it's not as if it doesn't. I'm not going to get into the benefits of liquid cooling. Of course, there's enormous benefits. But usually, in the end, it really just comes down to aesthetics, because Most of the systems being built these days, you have way too much flow, too much radiator capacity. It's really easy to cool a CPU and a couple of GPUs with the components that we have these days. So it gives you a lot of room to play around for aesthetics and theme and whatever else. But in this system, the GPU loop in particular is purely practical, and it needs to be extremely high performance. The design was absolutely critical. We're cooling off a huge amount of heat here, 7 times 280 watt TDP. The GPUs are very close together, and it would not actually run air-cooled. Even if you did have single slot air coolers, it would still just get way too hot. And so, yeah, this system would not actually run without the liquid cooling. So it was entirely necessary for practical reasons. The CPUs would run fine air-cooled with the 85 watt TDP. So I went for a parallel configuration there. Pretty much I was just couldn't help myself with the CPUs lined up the way they are. But it's also for practical reasons, because it would have been very big and bulky if I hadn't have done it in parallel, like really messy. So I wanted to keep things really clean for aesthetics and kind of for practical reasons. But the GPU loop, we could only fit two 360mm radiators in the case for the GPUs, an EKXE and an EKP. And that's not a lot for this amount of components. Also, the GPUs are in semi-parallel with the EK bridge. 4 of them are in parallel and 3 of them, and then they're joined. So you need a lot of flow to drive that. And you can see there's not much flow coming through here now because I'm only running one of the D5. So that second D5 was absolutely critical. And I wish I had have had more time for more testing to show you the test results, because when that second pump kicked in, it made an enormous difference. And there was also a sweet spot with the RPM curves for both the fans and the pumps. And any small changes to RPM just made an enormous difference to the temperatures. Like 300 RPM on the fans represented 12 degrees on the coolant. So that was very interesting to see.